Let's look at the derivative of ln x. First of all, ln is really, or ln x is really the logarithm of x with a base e, but it's written as ln. You remember that logarithms sometimes written as log of x. It really means log with a base of 10, base 10 log. But we're looking at the natural log, log with a base of e, the I log. Now, the fact is, when you have ln x, d by dx of ln x is equal to 1 over x. That's our standard result. But we want to look at it from first principles, alright? So, here, we want to find d by dx of ln x. What is it? Suppose we have a graph. The graph of ln x would look somewhat like this. And we choose this point as x. We can choose a further point out here by adding something to x. So it's x plus, let's call that something h. So it's x plus h. X here would correspond with f of x, which is ln x. And x plus h here would correspond with another point. It would be ln x plus h. Alright? Let's call this point 2 and this point 1. Now, from first principles, what you're looking at is the limit as h approaches 0 of the gradient here would be y2 minus y1, which is ln x plus h minus ln x divided by x2 minus x1. In this case, x plus h minus x. Well, you can see x minus x would be 0, so the x's would be gone. Alright? So we can get rid of those two x's here, they are gone. They subtract each other. Now, one of the properties of logarithms is that the log of one number, in this case this, minus the log of the next number is equal to the log of this number divided by this number. So let's see. We're looking at the limit as h tends to 0 of ln x plus h divided by x all over h. So you see that? But the thing is, this is the same thing as just multiplying everything here by 1 over h. So it's multiplied by 1 over h. Alright? So it's the limit of all of this. Now, another property of logarithm is that a number times the log is of the log of x is the same as the log of x raised to the power of that number. For example, n times ln x is the same thing as ln of x to the power of n. Alright? So, let's do that. Let's rewrite this in that form. So what you have is the limit as, not x, the limit as h tends to 0 of ln x plus h over x raised to the power of 1 over h. Good. Now you can rewrite what you have in the bracket here and say what you're looking at is the limit as h tends to 0 of ln in the bracket can be written as x over x plus h over x to the power of 1, and that to the power of 1 over h. But what is this? X over x, it's 1. So x divided by x is 1. So you can just write 1 there. It's 1 plus h over x. That is raised to the power of 1 over h. Alright. Now, suppose you say here, suppose you say that h over x, rewrite it in another form, is equal to 1 over another number, say y. Alright? 1 over y. What this would imply is that y equal, when you transpose, what will you get? It would be x over h. Alright? So y would be x over h in this case. Now, what do we have here? If y is equal to x over h, we would have the limit as h tends to 0 of ln, is ln what? Is 1 plus, if y is x over h, then h over x would be 1 over y. This would be 1 over y. And then that is raised to the power of 1 over x, 1 over h, I mean, that's 1 over h. Okay, good. Now, suppose we consider the 1 over h here. What would it really be? When we look at this, we can see that h is equal to x over y. So 1 over h would be y over x when we invert both sides. So this can be written as y over x. Alright? So let's rewrite this as y over x. It's to the power of y over x. Alright, good. Now, here, y is just a number because we had said before to let h over x equal 1 over y. So y would be a number here. So let's continue over this side. Let's erase some of what we had, or some of what we have here, and continue writing. Can erase this up here too to make some space. Alright, so in this case we're looking at the limit as h approaches 0 of ln 1 plus 1 over y to the power of, you can rewrite this as 1 over y to the power of y, and then all of that is raised to the power of 1 over x, because remember the laws of indices, a number raised to a power and all of that raised to another power. You can just multiply the powers and the number is raised to that one big power that you get when you multiply them. So in that case, or they raised to the product, I should say. Right? In that case, what we could do based on laws of logarithm, this is the same as 1 over x times ln of all of this. right? So we could say this is the limit as h approaches 0 of 1 over x times ln of 1 plus 1 over y to the power of y. Alright. Now, here, we could just multiply, since 1 over x here, since we have 1 over x here, we could just multiply, instead of saying the limit of 1 over x times ln, we could just say 1 over x times the limit is the same thing, the properties of limit, alright? We could just multiply everything by 1 over x. So 1 over x times the limit as h tends to 0 of ln 1 plus 1 over y to the power of y. Right. Now, what do we have here? If y is a certain number and y is getting larger and larger, then this kind of start looking like the Euler that we've seen before. But let's look at the h tending to 0. Here, if h becomes very, very, very small, what we have is h over x equal 1 over y. If h becomes very, very, very small and is going towards 0, at some point it goes to 0, then this side would be 0, right? What would have to happen so that this side becomes 0 too? Y would have to become a very large number. The larger y becomes, 1 over it approaches 0. So y would have to approach infinity. So we could change this h approaching 0 to y approaching infinity. Alright? So as h approaches 0, y actually approaches infinity. So y approaches an infinite number or an infinite value. Now, here, as y approaches infinity of ln 1 plus 1 over y to the power of y, all of this tells us that what we're looking at is what is called the Euler or the Euler. Alright? Now, or if we rewrite this, what we would have is 1 over x times ln e is ln e. You see that? As y approaches infinity, this approaches e. This value will approach e. Now, what is ln e? Remember the property of logarithm. Ln is really the logarithm with a base e. Ln x is the log of x with a base of e. But in this case, instead of x, we're using e. Equal a number, call it x. The log with a base of e is a certain number, right? Now, here, this number is saying, this e is saying, if you have e raised to the power of x, it will give you this. E raised to the power of x. Alright, let's put it this way. E raised to the x will give you this. Alright? but x would have to be 1. So therefore, ln e would be 1. The natural log of e would be 1. Alright? Because if x is 1, let me erase this and put the 1 there. If this becomes 1, and this is ln e, then ln e is 1. Alright? Now, if ln e is 1, then what would happen here? This becomes 1. So, therefore, what we can say is the limit of all of this as h approaches 0, in other words, the derivative d by dx of ln x is equal to 1 over x ln e. But since ln e is 1, then we just have 1 over x times 1, which is the same as 1 over x. So therefore, d by dx of ln x is equal to 1 over x. Right? So this is the result that we have. d by dx of ln x is equal to 1 over x. You should remember this standard result.